Yes, Charlie ZL2CTM. Hey, look, I'm just doing a quick check on a couple of audio amps. Let me just bring this earbud up to the microphone. Now, if you can hear me over top of that, that's using the LM380. Let me just switch to the 386. It's the audio coming through is the same, but you can really hear that high frequency hiss in the background. Let's go back again. So that's now on the LM380. And I'll just go back again. It's interesting. So I don't know if you could hear that well, but I assume you did, and I'll check the recording later on. So what I wanted to do this morning was just quickly make up an LM380's amplifier, which is just here. So let me see if we can see that. Yep, looks right. So LM380, essentially the circuit's out the back of the specification sheet for that one. Very straightforward, just bringing the audio in on a 1 microfarad capacitor across a 10k ohm pot. That's that black one there, and straight into pin 2. Very simple on the output, just a large capacitor. I didn't have a 470 of a small enough size that I wanted to use, so I just elected to use a 330 microfarad capacitor and that small resistor RC network on the end. Whole lot of pins there are all earthed, and then a number of pins which are just not connected at all. But I've used this one before, and in the 40 meter rig, which was this one here, I just wanted to compare it again, and indeed it seems to be quite a bit better than the 386. I do have some decoupling or that bypass capacitor in to up the gain on the 386, which has certainly been known to be a culprit for increasing noise. But you know, I needed that to get sufficient gain. But at the moment, I think I'm actually going to stick with the LM380. If I was to make that smaller, I wouldn't get much smaller than the footprint I have here, so I'm quite happy to stick with that. Also on that experiment just then, in line with the suggestion, was the high side injection. So just to work out where I have the two frequencies set. For low side injection, so not this example here, all I was doing was shifting my 3960 kilohertz signal with the lower sideband intelligence. Remember, this is a press carrier, but I've just drawn in there to indicate where the radio is tuned to, and I'm just transposing that up in frequency so I get the intelligence to sit in the middle of the pass band of the crystal filter, and then with the low side injection I had sitting on the high side of that filter the BFO frequency. With high side injection I now have the VFO sitting quite a bit higher than the crystal filter, so to make the maths work, in order to get this now transposed up to here, I have to add that frequency plus that equals that. Now the interesting thing with the maths for high side injection is I have what's called sideband inversion. So it's not just a matter of moving this up until it lines up with here, but actually things flip over. So if that's the case, then I actually need to have the BFO sitting on the low side of the crystal filter in order to recover that intelligence. So very similar to what we saw with the last video, but just with the maths changed a bit. That BFO frequency now is going to be 10.75 megahertz minus half the bandwidth of the filter, so in other words the distance from here to the end of the filter, minus another 300 hertz, which is that small gap there between the edge of the filter and my desired BFO frequency, which comes out at 10.748550 megahertz, and that's what I have channel 2 set for on the signal generator. Channel 1 on the signal generator is set to, if I wanted to receive 3.690 megahertz or 3690 kilohertz, as per this up here, I just add them together. So 10.748 plus 3.69 comes out at 14.438550, and that's what channel 2 is set to on this little experiment for the radio down here. And as I indicated, I think in the notes, no perceivable difference between either high side or low side. I guess one of the advantages of having the high side injection is I have the VFO frequency set further away from the working frequency, and certainly yeah, well away from the working frequency, which makes filtering a lot easier. And you'll notice here at the moment I don't have any filtering. I've elected just to play around with not having a bandpass filter on the input. And even though I have in the past with some more simpler radios had problems with broadcast band, so in other words the AM radio stations breaking through, I've got none of that here. So, and bearing in mind that this is designed or will be taken into the bush, I felt that wasn't actually a requirement. So next steps, I think for now I will just leave it on the high side injection. I am now going to swap out the two SBL1s for ADE-1s and just make sure that everything's still playing nicely there. And then I'm very happy with how it sounds on the receive side, so I don't think I'm going to do anything more to try and optimize anything. I will then shift focus to microphone amplifiers, and off we go. In line with the suggestion from when I put out the thoughts and ideas, I am going to use an old headset from a phone, which has, this is not an example of that, but it's the one where the microphone is in line, and I'll see if I can get that to work out what pins are the microphone and see if I can get it amplified up, which is, you know, just one less connector and cable to take while away. So that's the plan anyway. Take care, and like I say, I will look to scan those documents and put them up on the blog today. Anyway, take care, see you next time.